Good morning, students. Now in this class we are going to talk about protection. Okay, this is fifth unit, protection and security. See, already we have studied about what is a protection, what is a security. In previous classes we have studied about a brief introduction about the protection and security. Now in this class we are going to study about in depth about the protection concept. Whereas if you take the protection, generally if there is any kind of misbehavior with the resources or the files of operating system, then the technique of protection and security should be implemented so that there is no damage to the system. Generally, protection refers to a mechanism for controlling access of programs, processes or users to resources defined by the system. If you know about the protection, first we should know about the threats. There are two types of threats in any system. If you take any system, the possibility of the threats are two types. First one is internal threat and the second one is external threat. Okay. So, for example, what is meant by internal threat? If, for example, if you assume that if there are 5 users, that is user 1, user 2, user 3, user 4, user 5, and 2 resources, that is R1 and R2. Since 5 users are internal to the operating system, now suppose user 1 and user 2 are allowed to access resource 1. Similarly, user 3, user 4, user 5 are allowed to access resource 2, that is R2. Suppose if the user U3 try to access the resource R1, then that comes under the protection technique. So, internal threat or deals with protection technique. Whereas coming to external threat, so external threat is nothing but suppose there is a user at out, say X. X means out of the user. Try to access both the resources R1 and R2. Now, since the resources are external to the system, there should be some kind of security mechanism, that is firewall, that can block the access of X to the internal resources. This type of security is nothing but external. That is, this type of threat is nothing but external threat. Okay. So there are the two types of threats. Next, coming to what are the various goals of protection. Whereas coming to goals, we need some type of protection for several reasons. Okay, we need to provide protection for several reasons. The reasons are, first one is safe sharing of common logical address space or common physical address space. If we want to share safe sharing of common address space, then we are going to provide the protection. And next one is fair and reliable resource usage. If we want to use the resources, whatever we are using, fair, that means if we want to use the resources 100%, or if we want to utilize the resources, then we need to provide the protection. Okay. At the same time, avoid misuses activities by user and others. Okay. If you provide the protection, then there is no chance of mischievous activities, the miscellaneous activities by the others or by other users. Next one is to prevent intentional damage and violation of access restriction by user. We need protection. Okay. At the same time, in system, each program must use only allocated resource. Okay, if you have a good protection, then automatically each program must use only allocated resources. If you don't have any protection, then any person can use any type of programs. That is, any person can use any type of resources. If you have a protection, then the particular person can use the particular resource only to defend the system from unauthorized user. Okay, whenever there is a protection, then what will happen is the unknown person can't use the system. Okay, so for these reasons, we need to provide the protection. Okay, so these are some of the goals of protection. Okay, next, coming to principle of protection. Here in this principle of protection, if we want to implement protection enabled system, we must follow a principle throughout the design of a system. That is, one of the popular principle is a principle of least privilege. We will give enough privileges to the program, user, and even system to perform a task. Here, consider the analogy of a security guard with passkey. If this key allows the guard into just the public area that she guards, then misuse of the key will result in minimal damage. If, however, the passkey allows access to all areas, then damage from its being lost or stolen, misused or copied or otherwise compromised will be much greater. An operating system following the principle of least privilege implements its features, programs, system calls and data structures so that failure or compromise of a component does the minimum damage and allows the minimum damage to be done. If you are providing privilege of principle of least privilege, then we can say damage is very less. At the same time, such an operating system also provides system call and services that allow applications to be written with fine-grained access controls. It provides a mechanism to enable privileges when they are needed and to disable them when they are not needed. Okay. If the operating system will apply principle of least privilege, then create separate account to each user and the privileges are given that are necessary for user. Okay. Whereas next coming to domain of structure, that is domain structure. Before going to know the domain structure, we know domain of protection. Here in this one, domain of protection, a computer system is a collection of processes and objects. By objects, we mean both hardware objects such as CPU, memory, printer, disk, and tape drives, and the software objects just like files, programs, and some of us. Each object has a unique name that differentiate it from all other objects in the system, and each can be accessed only through well-defined and meaningful operations. Whereas in the domain of protection, the operations that are possible depend on the object. For example, on a CPU, we can only execute memory segments can be read and written, whereas a CD-ROM or we can say DVD-ROM can only be read. Data files can be created, opened, read, written, closed, and at the same time deleted. A program file can be read, written, executed, and deleted. A process should be allowed to access only those resources for which it has authorization. Furthermore, at any time, a process should be able to access only those resources that is currently required to complete its task. This second requirement, commonly referred as need to know principle. Okay, this is regarding domain of protection. Next, coming to domain structure. A process operates within a protection domain which specifies the resources that the process may access. Each domain defines a set of objects and the type of operations that may be invoked on each object. The ability to execute an operation on the object is an access right. A domain is a collection of access rights, each of which is an ordered pair, that is object name, right set. Okay, here object name and right set. For example, if a domain D has the access right file F, at the same time, next one is set is read and write, then a process executing in a domain D can both read and write file F. Okay. If cannot, however, perform any other operations on that object. At the same time, domains may share access rights. When we have three domains, D1, D2, D3 here, the access rights, that is O4, that is we have brackets print, okay, is shared by D2 and D3, implying that a process executing in either of these two domains can print object O4. Note that here a process must be executing in a domain D1 to read and write object O1, while only process in domain D3 may execute object O1. The association between a process and domain may be either static, if the set of resources available to the process is fixed throughout the process lifetime. Whereas if the association is dynamic, a mechanism is available to allow domain switching, enabling the process to switch from one domain to another. Whereas coming to a domain here, a domain can be realized in variety of ways. Here, first one is each user may be a domain. In this case, the set of objects that can be accessed depend on the identity of the user. Whereas the next one is each process may be a domain. In this case, set of objects that can be accessed depending on the identity of the process. Okay, so this is regarding domain structure. Next, coming to access matrix. See, what is meant by access matrix? So, access matrix generally, it is our general model of protection can be viewed abstractly as a matrix. That matrix is called as access matrix. The rows of the access matrix represents domains and the columns represents objects. Each entry in the matrix consists of a set of access rights. The entry access Ij, we can say Ij within brackets, define the set of operations that a process executing in domain Di can invoke an object Oj, like this. Okay, there are 4 domains and 4 objects and 3 files, F1, F2, F3 and 1 laser printer. A process executing in domain D1 can read file F1 and F3. A process executing in domain D4 has the same privileges as one executing in domain D1, but in addition, it can also write onto files F1 and F3. The laser printer can be accessed only by a process executing in domain D2. Here, we must ensure that a process executing in domain Di can access only those objects specified in row I and they only as allowed by the access matrix entries. Next one, domain switching can be easily supported under this model simply by providing switch access to other domains. Here, in the second table, processes should be able to switch from one domain to another domain. A process is executing in domain D2 can switch to domain D3 or to domain D4. A process in domain D4 can switch to D1 and one in domain D1 can switch to D2. At the same time, allowing controlled change in the contents of the access matrix entries require 3 additional operations, that is copy, owner and control. Okay, so this is regarding access matrix. Next, how we are going to implement the access matrix. Okay, this is implementation of access matrix. So here, implementation of access matrix, we are going to implement the access matrix by using 4 ways, that is global table, access list for objects, next capability list for domains, next lock key mechanism. Okay, if you take global tables, here we are going to store ordered triples, just like domain, object and write sets. Okay, a requested operation M on object OJ within a domain Di. We are going to search the table for DIOJRK. Okay. Whereas coming to access list for objects, each column is implemented as an access list for object, resulting per object list consisting of ordered pair, that is domain right set, defining all domains with non-empty set of access rights for the object. Whereas coming to capability list for domains, instead of object based, here list domain, in this one we are going to use the list domain. Capability list for domain is list of objects together with operation allows on them. Objects represented by its name or address called, we can say, capability. Next, whereas coming to fourth one is, that is lock key mechanism. In this one we are going to compromise between access lists and the capability lists. Each object has a list of unique bit patterns called logs, and each domain has a list of unique bit patterns called keys. And a process in a domain can only access objects if domain has key that matches one of the lock. Okay, this is the lock key mechanism. In this way we are going to implement the access matrix. Next one is access control. Access control is nothing but accessing a file in the system can be managed by access control only. For each file or directory access control, information is assigned such as owner, a file or list of user who can access the entity. In Solaris, generally Solaris 10 role-based access control, that is RBAC, is used, which follows a principle of least privileges. User can assign a role based on the resource they need or operations they perform. A user belonging to a particular role can be identified according to the login information. He or she type like password or username. At the same time, then based upon the role privileges are enabled or disabled for that particular user. Okay. So next one is, next we are going to talk about revocation of access rights. So in this one, in this revocation of access rights, the need to revoke access rights dynamically raises several questions, whereas immediate versus delayed. Here, if delayed, we can we determine when the revocation will take place. Next, selective versus general. Does the revocation of an access right to an object affect all the users who have that right, or only some users like this? With an access list scheme, revocation is easy, immediate, and can be selective, general, partial, total, temporary, or permanent is as desired. Next, when capabilities list, the problem is more complicated because access rights are distributed throughout the system. A few schemes have been developed that are included. The first one is reacquisition. Reacquisition means capabilities are periodically revoked from each domain, which must then reacquire them. And next one is back pointer. That is, in this back pointer, a list of pointers is maintained from each object to each capability which is helped for that object. Next one is indirection. Indirection means here capabilities point to an entry in a global table rather than to the object. Access rights can be revoked by changing or invalidating the table entry, which may affect the multiple processes. Okay, so this is regarding revocation of access rights. Next, whereas coming to next one is capability based systems. Whereas in this capability based systems, we should know about Hydra. One example is Hydra. Hydra is a capability based system that include both system defined rights and user defined rights. The interpolation of user defined rights is up to the specific user program, but the operating system provides support for protecting access to those rights, whatever they may be. Operations on objects are defined procedurally, and those procedures are themselves protected objects accessed indirectly through capabilities. Next, one more example is CAP system, that is Cambridge CAP system. The CAP system has two kinds of capabilities, that is data capability and software capability. Data capability, we are going to use it to provide read, write and execute access to objects. These capabilities are interpreted by microcode in the CAP machine only, that is Cambridge CAP machine. Whereas coming to software capability, it is protected but not interrupted by the CAP microcode. Whereas coming to language-based protection, in this language-based protection, as systems have developed, protection systems have become more powerful and also more specific and specialized. To refine protection even further require putting protection capabilities into the hands of individual programmers so that protection policies can be implemented on the application level. At the same time, here we should know, in this language-based protection, we should know about the compiler-based enforcement. In a compiler-based approach to protection enforcement, programmers directly specify the protection needed for different resources at the time the resources are declared. Whereas this approach has several advantages. The first one is protection needs are simply declared as opposed to a complex series of procedure calls. Next advantage is protection requirements can be stated independently of the support provided by the particular operating system. The next advantage is the mean of enforcement need not be provided directly by the developer. At the same time, next one is it declares a notation is natural. Declarative notation is natural because access privileges are closely related to the concept of data types. So these are the various advantages comes under language-based protection. Next, there are several areas in which compiler-based protection can be compared to kernel enforcement protection. That is, first one is security, flexibility and efficiency. Whereas if you take security provides by the kernel offers better protection than that provided by a compiler. The security of the compile-based enforcement is dependent upon the integrity of the compiler itself, as well as requiring that files not be modified after they are compiled. The kernel is in a better position to protect itself from modification as well as protecting access to specific files. Where hardware support of individual memory accesses is available, the protection is stronger still. Okay. Next, coming to flexibility. A kernel-based protection system is not as flexible to provide the specific protection needed by a individual programmer, though it may provide support which the programmer may make use of. Compilers are more easily changed and update when necessary to change the protection services offered or their implementation. Next one is efficiency. The most efficient protection mechanism is one supported by hardware and microcode. Insofar as a software-based protection is concerned, compiler-based system have the advantage that may check and be made offline at compile time rather than during execution. All these are the security, flexibility, efficiency. All these are the several areas in which compiler-based protection can be compared to kernel enforcement protection. Okay, so this is regarding language-based protection. Okay, thank you.